sides.
I mean, it's a very nice course. Places like that. It's a hard course.
Yeah.
Places I work, I like to see life.
Oh,
These questions on here have all been pulled from the last 4 air tests. So let's actually start with number 2. The first one on there is actually a fairly complicated, long problem. But that I started with last year's test and started working backwards, so that's why it's first, because that one was on last year's test. It's just a multi-part question, multi-steps. So we're gonna start with some other ones and build up to that one. Alright, so number 2 says we've got 2 triangles, and MNO is transformed to produce PQR. Okay, so transformed. Okay, we talked about 4 different types of transformations now: rotations, reflections, translations, and dilations. So it says pick all of the sets of transformations that would guarantee the 2 triangles are congruent. We've looked at 3 where we didn't change the triangle at all. We just moved it. Right? A rotation, a reflection, and a translation preserve size and shape. The original and the new triangles would be congruent. The one that we looked at yesterday, a dilation, does not preserve size. So the 2 triangles would not be congruent if we have a dilation. So all we're looking for in a question like this is any sets of transformations that don't include a dilation. So if we dilate it, they're not congruent. Dilate it, not congruent. Here, a reflection, then a rotation, that would preserve size and shape. Rotation, then a translation, that would preserve size and shape. Translation, and a reflection, that would preserve size and shape. Right? So on something like that, all we're looking for is just no dilation to preserve congruence. Right? Questions on something like that? Right, there's really no work to do for a question like that. It's just understanding that a dilation does not preserve congruence. The ones on the back, though, we will look at some work here. So number 3 says we've got a line, 6x minus 3y equals 5. And we dilate it, centered at the origin, with a scale factor of 6. So we want to figure out the slope after the dilation and the y-intercept after the dilation. Is that a hand? Okay. So normally, to put something like this into slope-intercept form, we would leave the y on the left side of the equation, move the x over here, and divide by whatever that coefficient is. Right, so yeah, if we want to think about trying this by hand, solving for y would probably be a good first step. Right, so to do that, subtract the 6x over up here, negative 3y equals negative 6x plus 5. Divide everything by negative 3, and we'll get y equals 2x minus 5/3. Okay. So we want to use a scale factor of 6 to move this line. Right? Now I think getting this picture on Desmos is going to be our best bet. Y equals 2x minus 5/3. Okay, so here's what that line, I froze it. Here's what that line would look like. So, yeah, and we know that point right there. What's up? Multiply what by 6? The whole thing? Well, let's try taking a few points and seeing what happens. Alright, so actually let me move this a little bit. Up here. So here are 2 points that we know the values of, right? And if we don't know the values of, we can use Desmos to tell us the values. So as a fraction, that's 5/6. And you can use a calculator to figure that out. And you know how to use the calculator to convert decimals to fractions. Math, frac. This one would then be the point 0, -5/3. That's our y-intercept. So if we're thinking about what we did yesterday, dilating a point with respect to the origin, all I'm doing is multiplying these coordinates by the scale factor. Okay, so if I multiply this by 6, I would still get 0. If I multiply this by 6, I would be at -10. -5/3 times 6 would be at -10. Okay, so this would be this point dilated with a scale factor of 6 about the origin. Do the same thing here. It's going to multiply these 2 coordinates by 6. So 5/6 times 6 is going to be 5. And 0 times 6 is going to be 0. So I connect those 2 points. What do we notice about our original line and our new line?
Parallel.
They're parallel. So dilating a line did not change the slope. The slope stayed exactly the same. What did change, though, was the y and the x-intercept. So the line will move when we dilate it, but the slope will not change. Just by 6.
And then
The slope of 2? Yeah, so what we did, we just took these 2 individual points that we knew were on the line. We could have done that with any 2 points on the line, but these were just given to us by Desmos because they were the intercepts. So since we're dilating with respect to the origin, we just took both of these sets of coordinates and multiplied them by 6 to get these 2 new points. And what we can see then when we connect our 2 new points is our new line is parallel to the old line. So the slope doesn't change. You can pick any 2 points, yeah. But the intercepts are probably easier to pick. Okay, so to go back and answer the question now. Okay, the question wanted us to find the slope and the y-intercept. Alright, the slope is still 2. And then the y-intercept So if we want to be full equation of the line, it would be y equals 2x minus 10. Right? Now, we do want to make sure that we're careful when we're putting in these values. Right? The slope is just 2. It's not 2x. Right? It's not, we don't include the variable when we give the slope. The slope is just the number 2. And then the y-intercept is just -10. You okay with something like that? Now, I didn't include the other example, but a question just like this has showed up multiple test. Right? So this is one that we want to feel comfortable with. Right? Odds are we'll see something like that on the air test. Okay? The next two then are pretty closely related. We just have a picture for one and no picture for the other one. It actually, so this one doesn't specify what we are dilating about, but to answer the question, it doesn't actually matter. I'll show you why. What's that? Yeah, so it says we've got some new triangle, A prime, B prime, C prime, that's created by dilating this triangle, ABC, by a scale factor of 4. Okay? It doesn't tell us where we're dilating about, right? But it doesn't matter because it doesn't ask for any coordinates. It just asks for the length of A prime, B prime. So we talked about this idea yesterday that the side lengths change by exactly the scale factor. So if I can find the length of AB to get the length of A prime, B prime, I would just multiply the length of AB by 4. So one way that we could do that is the distance formula, Pythagorean theorem, which the distance formula is just Pythagorean theorem. And we've talked about that a little bit already, but I mean, once we actually do Pythagorean theorem, I'll show you the reason behind it. Wait, say it again. Yeah, so all we care about here is the distance between A and B. So this would be the point 1, 4. This is the point 4, 8. Yes, it is. Okay, so distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll have my x's would be 4 minus 1, and my y's 8 minus 4. So we get 3 squared plus 4 squared, which is 9 plus 16, which is the square root of 5, which is 5. There was a question like that. Right, so the length of AB is 5. Therefore, the length of A prime B prime is 4 times that, which would be 20. Are you? So you're saying like that? Yeah, I suppose you could write it like that. All right. Questions on something like that? Okay. So then the last one on here is a similar question. There's just no picture to go along with it. We're just given the coordinate points for our figure. And then it says we're dilating by a scale factor of 1/2. Okay. So give this one a try here. Okay. We're given our vertices, A, B, and C. And we're dilating by a scale factor of 1/2. And we want the length of B prime, C prime.
6.2. That's nasty.
And then we have to turn this like 5 every time.
Eventually.
Okay.
6.2.
Let's put 5 to the side.
This should come out to a nice number. So keep all of the values of the decimal. This should just be 6.5.
I put that in the calculator 6.5 plus 36.
How did you do 5? Are we supposed to be the 40?
I have it.
Oh,
The beans right there.
So you have to do the distance.
They actually have to say
No, it'd be 3.2.
I am.
no, you could do it either way. You could
See,
it first, and then find the distance between B prime and C. That would work too, since you get 3.25.
Surprise. I'm just trying not to. I'm a cat. Sometimes a catapult. Because I need it to
what do I take?
because everybody needs it.
Should I take steel drums?
Yeah.
That actually sounds fun though.
You wouldn't even have to though. You'd have your own.
Yeah, no, but steel drums sounds fun. Maybe my CD here.
It's basically going out.
Oh, but it's all color.
Did we get
No, she-
3.25
Maybe with
for our
stem-
final
I
answer?
didn't say that.
So for this one, there's a couple of ways we could have done this. Okay, we could have done this just like we did the last one and find the length of our original side, which is what I did. I found the length of BC and then multiplied that by the scale factor. We could have actually also, since we are told, well, actually, it doesn't even matter where we're dilating about, but we could find our B prime and C prime first. So I could just cut these values in half and say B prime is at 1.25, 1.5, and C prime is at 0, negative 1.5, and then find the distance between those points. And we should get 3.25 if we do that.
I was going to do that. That makes sense. You know, because then like 20 and a half.
I think the how I do the language when I got what in life I could just the square root of 16 times for nothing. 42
What, you have the square root of 6.5?
it would be why like that.
I don't know. You must have done something.
I got 6.5 though.
The square root of 6.5 or 6.5?
Square root of 6.5.
I don't know. I'll look at it here in a minute. Okay, but any questions on process to do a problem like that? Maybe eventually. All right, so let's go back to the first one now. this one, we've got two triangles, ABC and DEC. So it says that Katie shows the two triangles are similar. Similar is something we have not quite talked about yet. It's coming later in this chapter, but we don't really need to understand what similar is to do this problem, right? It says she performs these transformations. She takes triangle ABC, rotates it, then dilates it, and then translates it to get to this larger triangle. We have to figure out how she did that. Okay? So, the first thing, we're rotating this triangle about point A 180 degrees. What would this triangle look like after I rotate it 180 degrees about point A? So it'll be flipped around over here. Okay? So we talked about rotating points. We spent a lot of time about the origin, and we spent a little bit of time rotating rotating figures about points other than the origin. Okay? So rotating 180 degrees, remember the idea is I'm just going to take each point, figure out that distance, and then for 180 degrees, I'm just going straight through that same distance. Okay, so if I'm rotating about point A, obviously A is going to stay in the same spot. But then from B to A is a distance of 4, so then I'm going to stay on that same line and go a distance of 4. My B prime would be right here. Same thing for C. Okay, we want to see how far we're going straight to that line. Now, we could just count, I'm going up 3 over 4, so then I would do that same thing, up 3 over 4, to get to where C prime would be. That wasn't a guess. Well, I knew that's where I was going to end up. So yeah, to figure out the scale factor now, we want to look at this triangle and compare it to the larger triangle. So my goal is to make this small triangle exactly like the big triangle. So I want to look at the length of a side. Right? I can compare the length of C prime B prime here, which would have a length of 3, to the length of this corresponding side, ED, which has a length of 6.
So you don't have things that grid, and it was just a triangle and that. Can we do this with the two triangles and from A to C, regular A to C, and then A to E, that fits it, and then A to B, A to E prime.
Since A is the midpoint of C and E here, yeah, that logic would work. Yeah, because we're saying that this side ends up being exactly half of that side, because A is the midpoint. Yeah, that would work.
So this K.
So to answer this part, K would equal 2. Our scale factor is equal to 2. So let's actually do that dilation now. Okay, so it's saying we're dilating A prime, B prime, C prime with a center at A. Okay? So I can see from A to B prime, that's a distance of 1, 2, 3, 4. So if I'm using a scale factor of 2, I'm just going to double that distance. So I'm going to go a distance of 1, 2, 3, 4, 5, 6, 7, 8. So the length of A prime, B prime is 4. And we're doubling that. We determined that our scale factor is 2 to make this smaller triangle the same size as the larger triangle. So I'm just going to go a distance of 4 times 2 then to get to be double prime. Okay. Then I'm going to do the same thing for C prime. From A, I'm going up 3, left 4. So I'm going to double those. I'm going to go up 6, left 8. So up 1, 2, 3, 4, 5, 6, 7. Whoops, up 6, left 8. 3, 6, 1, 2, 5, 6, 7, 8. Yes. So it does go off the grid that they give us. But this is where my new A, oops, I labeled that wrong. That's C double prime. Yeah. What are you confused about? Oh, because I put A double prime there. Sorry. So this is where our new triangle is after the second bullet. We okay with that?
Yes.
So then finally, so she translates P units to the right and Q units down to get this triangle on top of CDE. How far am I moving?
Oh, up. 4 down, it's 4 and 3.
So the final bullet says we're taking this triangle and now moving it P units to the right and Q units down to get it to match up, to get it to sit on top of CDE.
P is 4. Would it be half or annihilation?
No, the scale factor will be 2 because we're multiplying the distance by 2. We're making it
I
bigger.
meant like, when you go annihilation, you get the you just 4, where you go over 4, because it was stacked.
Yeah.
Yes. Because we did A and B is 4 and annihilation makes it 8
Yeah.
away, and it so it moved it over 4. We say we just
You have to take Spanish too.
agree to look at, and
I've
we were able to say because it was
So are you trying to get a full schedule, or are you trying to have a study?
4 right and down.
Yeah, I see what you're saying. Yeah, because we just doubled that distance, so that distance
I'm
then
not
is 4.
gonna have to have it. I mean,
And
I want to
back
take
over
one
4.
sixty,
Yeah.
but I'm gonna have a schedule.
Yeah. So yeah, I think most of us have the answer now. We can just look at a single point. We don't have to look at all 3 coordinates. But to move, we can look at any of them. To move A down to C, we're going down 3 and then right 4. So P units to the right, that would be 4 units to the right, and Q units down is 3 units down. Okay? So our answers are A equals 2, P equals 4, Q equals 3 for something like this. Okay, so this one was a little bit longer of a problem. This one was actually worth 2 points on the air test. Most of the questions on the air test are only worth 1 point. This was a 2 point. Right, so this